In this video, we'll be solving questions that require constructions, that is geometrical questions. So, in this first example, we've been given this and we've been asked to find this angle x. So, remember we said these questions require construction. These are parallel lines. So what we usually do when we have parallel lines is to, since the angle we are looking for does not involve parallel lines, we have to construct another parallel line that can pass through. That is another line that is parallel. So I'm going to be doing this with pencil and broken lines. So this is our construction, and once we do that, we have this new angle. I'm going to call this A. I'm going to call this B. That is from here to here is A. Then this angle is B. And then we'll extend all these lines. We'll extend the parallel lines. When we do that, so this is AB. I'll call this C. And then call this angle D. So extending all these lines have introduced new angles to us. So this x we are looking for, we know is equal to angle A plus angle B, right? Good. And when we have parallel lines, we expect to see alternate angles and corresponding angles. Now, when we look carefully at this, we could see that angle A will be equal to angle C because they are alternate angles. These are parallel lines, right? And then when we look carefully, we see that angle B will be equal to angle D because they are also alternate angles. Now, the first thing we are going to do is to find angle C and angle D. We equate them to angle A and angle B, and then we add them up to get angle X. So quickly, we have that angle C, or 110 plus angle C, is equal to 180 degrees, and our reason is angles on a straight line. Angles on straight lines, on a straight line. Okay, so we have that angle C is equal to 180 minus 110 degrees, which is equal to 70 degrees. So going over to angle D, we have same thing, angle on a straight line, that angle D plus 120 degrees is equal to 180 degrees. So the same reason we have here, and then angle D is equal to 180 minus 120 degrees, which is equal to 60 degrees. Beautiful. So now we go over to angle A and B. We have that angle A is equal to angle C, and angle C we found to be 70 degrees. And our reason is alternate angles. Alternate angles. And then we have that angle B is equal to, did you see that alternate angles? So these are parallel lines, and this is a transversal passing through it. So as this is on this side, this is on this side. So B is equal to D, and D is equal to 60 degrees. And then same reason, alternate angles. So you can see we are done. We have that angle X is equal to angle A plus angle B. Therefore, X is equal to angle A is 70, angle B is 60, and then angle X is 70 plus 60, which is 130 degrees. And that's all. Here we have our second example. So it goes on like the first. We have to find angle X. So remember what we do. We are going to extend all our parallel lines. We extend our parallel lines, make them longer. So I'm doing this with a pencil and broken lines. And then, since the angle we are looking for is not rounded on a parallel line, we are going to add a parallel line to it. So these are parallel lines. So having done that, we have new angles formed. So we have this angle here, we have this other angle here. We also have an angle here, we also have an angle here. So looking at this, we could see alternate angles, right? And then we could also see alternate angles. So we need these three angles. This one, for this example, we don't need it. So I might call this angle A, B, C. So I'll start with A. I will say that 105 plus angle A is equal to 180 degrees. And our reason is angles on a straight line. Straight line. Okay, we have that angle A is equal to 180 minus 105, which is equal to 75 degrees. So that's for angle A. And then we can see this is parallel, this is parallel. So this is the transversal. So angle A is equal to angle B, which is equal to 75 degrees. And our reason for making this statement is alternate angles. Alternate angles. Okay, so now left with angle C, we could see the alternate angles, right? So we see that angle C is equal to 20 degrees, and our reason is what? Alternate angles. And therefore, angle X is equal to angle C plus angle B, which is equal to angle C is 20, angle B is 75. 20 plus 75 is equal to 95 degrees. So angle X is equal to 95 degrees. Now we have this next example. So here we have our angle X here. So like we've already been learning that the first thing we do is to get a parallel line along this angle we are looking for, and then okay, we could see alternate angles. So we don't even need to extend these ones in this case, because we could see alternate angles, right? We get this angle, we get this angle, and then we use angle at a point to find X. So the first thing is always to draw a parallel line across this one you're looking for if it's not along the parallel lines. Like if it doesn't have a parallel line passing through it, and then you check for alternate and corresponding angles. Okay, so here we can form angle. Okay, we have ABCD already, so as not to confuse with the line, the angles. So this is X, Y, Z. Okay, let me say U, angle V for this other angle. This is angle U, this is angle V. Then this angle over here, UV, so this is angle WX. Beautiful. So these are the three angles we need to find angle X. Okay, so we can see that angle U is equal to 52 degrees. So these are alternate angles. Angle U is alternate 2, so alternate angles. Okay, and then V is an alternate angle, like V and W are alternate angles, but we don't know W, but we can get it from angles at a point here, right? So we get angle W first. We have that W plus 312 degrees is equal to 360 degrees. Angles at a point. Angles at a point. Okay. And then we have that W is equal to 360 minus 312, which is equal to, we have 8, 5 minus 1, we have 4. So 48 degrees. That is for W. And then we have that V is equal to W, which is equal to 48 degrees. And the reason is that they are alternate angles. Okay, having found U plus V, we now have that we can find X from here. We have that X plus U plus V are all equal to 360 degrees, and our reason is that they are angles at a point. Angles at a point. Okay, so we have that X is equal to 360 degrees minus U. U is equal to 52 minus V. V is equal to 48 degrees. So we have that angle X is equal to 260 degrees. Now on to the next example. So remember, the first thing we do is to extend the parallel lines, right? And then this time around, what we are looking for is along a parallel line. So how do we find X? We have that this is 3x, this is 40, this is X. Okay, when we've extended, so this is the construction we do to extend the parallel lines. When we've extended the parallel lines, we can notice an angle here, a triangle here. And then we can see that alternate angles. Remember, whenever we have parallel lines, we should be thinking of alternate and corresponding angles. We have alternate angles. So this point is also equal to X. So this is an alternate angle. Okay, and once we have the alternate angle on this part, so if here is equal to X, we know that here will be 180 minus X because they are angles on a straight line. And this point is 180 minus 3X, which is because they are angles on a straight line too. So having seen that this is X, this is 180 minus 3X, we can also use exterior angles of a triangle, because we can either have that here is 180 minus X and then have that these two angles are equal to this exterior angle, or we could have this as our exterior angle. So these two angles are equal to this exterior angle here. So any one of our choice. Now I might decide to say 180 minus X. Since here is X, so this point is 180 minus X. Reason. So this is alternate angle. This is angles on a straight line that gave us this. So we can now say that 40 plus 180 minus X, this is in a bracket, are equal to 3X. So, and our reason for making this statement is exterior angles. Exterior angle of this triangle. Okay, when we have that, we collect like terms. We have that 40 plus 180 is equal to 220 degrees. And then we had 3x on this side. 3x minus x comes to be plus x. So we have that 220 degrees is equal to 4x. We divide both sides by 4. We have that 2 here is 2, 2 here is 11. Okay, 2 here is 1, and then we now have 5 degrees equal to x. So x is 55 degrees. So same thing with this next example. We have to extend the parallel lines. And for this one, we also notice another triangle. So we extend the parallel lines, we notice another triangle. And then our x is here. It's not on a parallel line, but it's within a triangle, so we can always find this. You know, we can actually find this angle here, right? We can find this angle because as this is a straight line, so 241 minus this 180 degrees, the angle on a straight line, we get this angle here. And then we already have x. Then remaining this angle. Now for this angle, can we see where 89 degrees is? and we can see these are parallel lines, right? As this is here, this is also here. So these are corresponding angles. This angle is equal to 89 degrees and our reason is corresponding angle. So if you want to solve this, like to show all working, you can name this angle A, for example, and then just name this part angle B, for example, and then you can always find your angle B. You can always, like, angle A is equal to 89 degrees, reason corresponding angles. Angle B is equal to 241 minus 180, then we get our angle B. So let's get on to it. So this is 89 degrees. Then for angle B is 241 minus 180 degrees. That's to remove this angle on a straight line. We have 1 and then 14 minus 8 is 6. So we have 61 degrees here. Good. So we have our angles in a triangle and x is the remaining one. So x plus this are all equal to 180 degrees. Reason angles on a straight, angles in a triangle. So we have that angle x is equal to 180 minus 81 minus 60. No, 89 minus 61. And when we add up these two, so this is 90 plus 60. So x is equal to 30 degrees. As simple as that. So you could actually see that there is a pattern here. Once parallel lines are involved. Let's do one more example before we go, so as to ensure that we always follow the pattern. Okay, so we extended our line, right? So these are parallel lines. You can as well extend this, but this is enough because that's where we have this angle. So we can see as these are parallel lines, this angle is here, this angle is also here as 130 degrees. So our reason for saying that this angle is 130 degree is corresponding angles. They are corresponding angles. And now we can always find these angles within the triangle because these are straight lines, right? We find the angles within the triangle. You can go ahead, pause the video, solve, and then come back to tell us what x is. So having seen that this is 50 degrees, this is 60 degrees, you can always find x. So x is equal to 180 minus these two angles. Or you could just say, you could use exterior angles, anyone. Okay, 180 minus 60 plus 50, that is 110. Okay, and then we have that x is equal to 70 degrees. So you can see that solving these are very simple.